Alright, so I want to solve this system of equations by reducing the augmented matrix. Shout out to Christopher Yamuchi for asking this question. So to solve this using a matrix, first you create the matrix using the coefficients. So 1, 1, 2, 4, 5, 5, 0, 0, 4, 0, negative 1 and 2. And then we want to make all of these guys 0. So we're going to take the first row and multiply it by negative 5. So 1, 1, 2. Well, actually, let me do it like this. 1, 1, 2, 4. Multiply that times negative 5. I get negative 5. Negative 5, negative 10. Negative 20. Below, I'll put second row, 5, 5, 0, 0. I'll add those together. I get 0, 0, negative 10, negative 20. I'll divide that whole row by negative 10 and get 0, 0, 1, 2. So I'm going to call that 2 star. 2 star. Alright, that's my second equation. Now I'm going to get rid of this 4. So what's the opposite of 4? Negative 4. So I'll do the same type of thing. So negative 4 times 1, 1, 2, 4. I'll get negative 4, negative 4, negative 8. Negative 16. I'll take this third row, put it beneath it. 4, 0, negative 1 and 2. I get 0, negative 4, negative 9, negative 14. That equation is irreducible. I can't really simplify it. I'm going to rewrite the matrix. 1, 1, 2. Oops, messed that line up. So I'm going to go ahead and do some. I'm going to switch the rows. I'm going to do this 1, 2, and then I'll do 0, 4, 9, 14. I can at least multiply this by negative 1, right? So now I see how I switched rows 2 and 3 because I wanted to get like an upper triangular matrix where all of those are 0. This is the stage we want the matrix to be in. So we can do backwards substitution now. Backwards substitution. And it's pretty easy. You just start with the bottom. Remember, this is like x. What is this? What are the variables here? x1, x2, x3. So this 1 is in the x3 location. So you can say x3 equals 2. Or if you want, you can kind of go back to the system now. So you can say this is like x1 plus x2 plus 2x3 equals 4. 4x2 plus 9x3 equals 14. And then like x3 equals 2. So you see how we already have x3, so we just substitute that in. So we'll say like 4x2 plus 9 times 2 equals 14, see? So 4x2 plus like 18 equals 14. So 4x2 equals what? Negative 4. So x2 equals negative 1. And then we go x1 plus negative 1 plus 2 times x3, which was 2, equals 4. So these 4's kind of cancel each other out. So you just get basically x1 equals 1. So our solution would be 1, negative 1, and 2. So that's how you solve this using a matrix. So I only want my students to make a matrix up to this stage here and then use backward substitution. So that's it. That's the answer.